If you're watching this and you haven't subscribed yet, what you're about to hear will change how you understand tank warfare, and honestly, how you understand engineering itself, because this isn't just a story about metal and firepower. It's about the moment when the Soviet Union looked at German superiority, refused to accept mythology, and built something better. So hit that subscribe button, because we're going inside the war machine that terrified the Red Army, and what happened when they finally got their hands on one. January 1943. The Eastern Front bleeds cold. Outside Leningrad, where the siege has already starved 500,000 people, a German Panzerwaffe column pushes through frozen marsh and pine forest. The Tiger tank is new, frightening, nearly invincible in the eyes of Soviet tankers who've watched their T-34s, the best medium tank in the world, bounce shells off its frontal armor like stones off ice. But on a reconnaissance patrol near Sinyavino, two Tiger tanks of the 1st Company, 502nd Heavy Tank Battalion hit soft ground. One bogs down completely. The crew abandons it, setting explosives to destroy the engine and gun, but the charges fail. Within hours, Soviet forces recover the machine intact. What happens next will shape the rest of the war. The Tiger is hauled westward, loaded onto railway flat cars, pulled deeper into Soviet territory through snow-covered landscapes and military checkpoints where NKVD officers watch and note everything. Command decisions ripple downward. This tank goes to Kubinka. This tank goes to the scientific proving grounds outside Moscow, where test engineers and designers already gathering data, already questioning German invincibility, will tear this machine apart and put it back together again. And they will learn things that will reshape Soviet armor doctrine forever. The journey to Kubinka takes weeks. The Tiger moves like a caged predator, massive and alien on Soviet rails. Engineers watch it during each stop, documenting every detail. The sloped armor, the interlocking road wheels, the mechanical complexity that German factories achieve with precision tools and centuries of industrial culture. But they also notice something else. Mud in the suspension, corrosion on the internal mechanisms. The Tiger, for all its reputation, is temperamental. It requires constant maintenance. It consumes fuel at rates that would bankrupt supply lines. It is, in human terms, a demanding thoroughbred in an army that needs reliable workhorses. At Kubinka, the Tiger disappears into a compound surrounded by security and secrecy. Doors close. Soviet engineers, tank designers, ballistics experts, metallurgists, mechanics converge on this single machine with the intensity of scientists who know they are looking at the source code of an enemy's power. They photograph every rivet. They measure every angle. They document the gun's recoil system, the turret traverse mechanism, the fuel consumption under load. And then they begin to dismantle it. Layer by layer, plate by plate, they expose the engineering logic underneath. The testing protocols are exhaustive. The 88mm gun fires at captured Soviet armor. Engineers observe the ballistic performance, the muzzle velocity, the penetration profiles at various distances and angles. They learn that the Tiger's gun is not simply bigger. It is fundamentally more advanced in its capacity to accumulate and project kinetic energy downrange. At 1,000 meters, where a Soviet 76mm gun might struggle to penetrate, the 88mm gun punches through with devastating consistency. The gun's optics are tested next. Soviet tankers had relied on inferior sights, cramped fields of vision, mechanical solutions that lag behind German optical precision. The Tiger's gun sight offers something revolutionary: magnification, clarity, the ability to spot targets at distances where Soviet gunners are essentially blind. This is not a small advantage. In tank warfare, the ability to see your enemy before he sees you is the difference between victory and death. The armor comes next. Soviet engineers measure thickness, 100mm on the frontal hull, 80mm on the sides. But thickness alone does not determine protection. Angle matters. The Tiger's designer, Henschel, understood that sloped armor, armor that angles backward rather than standing vertical, creates ricochet potential and increases effective thickness through geometry. A shell that might penetrate 100 millimeters of flat steel hits sloped steel at an oblique angle and either bounces away or buries itself at a steeper trajectory, traveling deeper through the armor package. Soviet engineers measure these angles, calculate the ballistic equivalencies, and realize that the Tiger's effective armor protection exceeds its nominal thickness by a factor that changes everything. But testing also reveals weaknesses. The lateral armor is thinner, only 80 millimeters, and the angles less favorable. The rear armor is thin enough that a Soviet anti-tank gun firing from behind stands a reasonable chance of penetration. The turret ring, the mechanical connection between turret and hull, is a potential point of failure. The suspension, while advanced, is mechanically complex, requiring parts that German factories struggle to produce in sufficient numbers. The fuel consumption is extreme. The transmission is prone to overheating under sustained load. The Tiger, in other words, is not invulnerable. It is superb within specific combat parameters, but those parameters are narrow, demanding, and exploitable. Soviet designers absorb all of this data. They study the Tiger's gun, and they begin designing a new gun, an 85mm weapon that will become the standard for the upgraded T-34-85. They study the Tiger's armor layout, and they adjust the angles on Soviet vehicles to approach similar ballistic equivalency. They study the Tiger's optical systems, and they begin importing and manufacturing improved gun sights. But the most important lesson is tactical and doctrinal. The Tiger cannot be fought head-on by medium tanks. It must be engaged differently, in ambushes where Soviet tankers use superior numbers and terrain. It must be attacked from the rear or flanks. It must be suppressed by artillery before it can bring its superior firepower to bear. It must be approached with infantry support, with anti-tank guns positioned at strategic points, with the understanding that defeating German armor requires integrated tactics, not just superior tanks. The implications cascade through Soviet command structure. Design bureaus receive new directives. The heavy tank program accelerates. Stalin and his generals, informed by the Kubinka tests, understand that Soviet industry cannot simply match German precision, but it can match German firepower through different means: greater caliber, heavier shells, thicker armor, even if that means slower, less agile vehicles. The IS series begins to materialize in design bureaus, the IS-1 and then the IS-2, with its massive 122mm gun, a gun so powerful that it does not need to compete with German firepower on terms of ballistic precision. It simply overwhelms. A 122mm shell fired by an IS-2 will penetrate any German tank in existence, even the Panther, even the Tiger. It will kill it in one shot. Simultaneously, Soviet engineers begin designing assault guns to counter German heavy armor. The Su-152, with its 152mm gun, officially a howitzer, technically a mountain gun, operationally a tank destroyer, emerges from these same research conclusions. Later will come the ISU-152, mounting the same massive gun in a fully enclosed turret. Soviet tankers will call it Zveroboy, the beast slayer. These weapons are not elegant. They are heavy, slow, difficult to manufacture, prone to mechanical problems, but they are formidable. They represent a different engineering philosophy, not precision and reliability, but overwhelming firepower delivered with sufficient armor protection to survive on a battlefield increasingly dominated by anti-tank weapons, artillery, and aircraft. The Kubinka tests also reveal something psychological. Soviet officers and soldiers, many of them convinced that German technology is inherently superior, that German manufacturing precision is unmatched, that German engineering operates on principles beyond Soviet reach. All of this mythology gets questioned. The Tiger is superb, yes, but it is superb within specific contexts. It is not invincible. Its armor can be penetrated. Its gun, while superior, does not guarantee victory against coordinated opposition. Its mechanical complexity is both strength and vulnerability. German engineers have solved certain problems with brilliant solutions, but those solutions create new problems. Soviet engineers, with different resources and different constraints, begin solving those problems through different means. This realization is transformative. It unlocks permission for Soviet industry to pursue its own path rather than attempting to replicate German achievement. The war itself validates these conclusions. The Tiger, throughout the remainder of 1943 and into 1944, remains a formidable weapon. Soviet tankers respect it, fear it, organize tactics specifically to counter it. But Soviet armor development accelerates. The T-34-85 enters production and proves that an upgraded medium tank with better gun and improved vision systems, informed directly by Tiger analysis, can compete effectively. The IS-2 arrives on the Eastern Front in 1944 and becomes the psychological equal of the Tiger. Soviet tankers now have heavy tanks that can meet German heavies as peers rather than prey. The captured Tiger itself, the specific machine that arrived at Kubinka in those frozen February days of 1943, becomes a reference point, a specimen, a teaching tool. Soviet engineers continue studying it for years. They photograph it from every angle. They reproduce parts for testing. They use it to train engineers, to demonstrate principles, to validate calculations. In 1945, as the war ends and Soviet forces push toward Berlin, variants of knowledge derived from this single Tiger flow through the entire Soviet tank corps. Every T-34-85 crew carries in their tank design and tactical doctrine principles learned from examining the machine that once seemed unbeatable. The broader lesson extends beyond tanks to technology transfer and industrial espionage. The Soviets, throughout the war, acquired German weapon systems, not just tanks, but aircraft, artillery, small arms, wherever possible. They study them methodically. They extract principles. They adapt these principles to Soviet manufacturing capabilities and Soviet doctrinal requirements. It is systematic, technological intelligence, elevated to a state function. The captured Tiger is one example among many, but it is perhaps the most symbolic, a single machine that becomes the foundation for answering a strategic question. How do we defeat German armor? Historians often mythologize the Tiger as invincible, as the apex of tank design, as proof that German engineering surpassed all others. The Kubinka tests complicated that narrative. The Tiger was excellent, but it was excellent within specific parameters that Soviet industry could circumvent through different engineering approaches. The Tiger was reliable in German production contexts, but temperamental in field conditions. The Tiger was powerful but not beyond defeating. This realization, captured in technical reports generated at Kubinka and circulated through Soviet design bureaus and military command, became as important to Soviet victory as any tactical innovation. By 1944, as Soviet industry reaches full production capacity and German industry, pounded by strategic bombing, begins to decline, the Tiger's advantage erodes. Soviet production lines churn out T-34-85s by the thousands. Heavy tank production intensifies. Anti-tank gun production accelerates. Soviet tankers, trained in coordinated tactics, in using terrain, in emphasizing numbers and firepower distribution over individual tank performance, increasingly prevail in tank engagements. The Tiger remains dangerous, but no longer decisive. It becomes one weapon among many in an increasingly industrial, increasingly attritive form of warfare, where production capacity matters more than engineering perfection. The war ends in May 1945. The captured Tiger at Kubinka survives the war. It's eventually displayed in Soviet military museums, still bearing the scars of its combat history, still serving as a monument to the moment when Soviet industry decided to stop imitating German precision and instead pursue its own technological path. Post-war analysis, informed by this captured Tiger and many other German weapons examined after victory, shaped Soviet tank design for decades. The IS-3, the T-44, the T-54, all carry within their engineering legacies the lessons learned from studying this single German machine. What the Tiger tank represented ultimately was not an unbridgeable technological gap, but rather different engineering philosophies applied to similar problems. German engineers, with access to precise machine tools and trained labor, designed for elegance and reliability. Soviet engineers, with different resources, designed for robustness and simplicity. German tanks were often superior in isolation. Soviet tanks, increasingly, were superior within the total system of warfare, logistics, production rates, doctrinal integration, industrial capacity. The Tiger was the apex of one approach. The T-34 and its successors represented the strength of another. The real victory at Kubinka was not military, but intellectual. Soviet engineers proved to themselves and to their leadership that they did not need to achieve German perfection to achieve victory. They needed to understand German design, extract principles, adapt those principles to their own manufacturing reality, and then field weapons in sufficient numbers with sufficient tactical innovation to overwhelm. The captured Tiger provided the proving ground for exactly that process. It provided data. It provided confidence. It provided, perhaps most importantly, permission to stop worshipping German engineering and start building Soviet engineering instead. When you think of the Tiger tank, remember not just its reputation, but its vulnerabilities. Remember that every Tiger faced multiple T-34s. Every Tiger encountered coordinated anti-tank defenses. Every Tiger operated within supply lines that strained and eventually broke. Remember that Soviet industry, analyzing a captured Tiger, learning its secrets, understanding its limitations, built a response that ultimately proved more effective, not because individual Soviet tanks were superior, many were not, but because the entire system proved more resilient. The Tiger was a masterpiece. But the Soviet response to the Tiger was a masterpiece of different kind. Not engineering perfection, but strategic intelligence applied to industrial production and applied to tactical doctrine. The machine that captured in frozen marshes outside Leningrad in January 1943 shaped the trajectory of tank warfare for the next decade. It shaped Soviet design. It shaped Soviet doctrine. It shaped Soviet understanding of what was possible. In a war where Germany's greatest strength was its engineering culture, and Soviet's greatest strength was its capacity to rapidly learn and adapt, the Kubinka tests represented the moment when Soviet adaptation began to overcome German superiority. It represented the instant when the direction of the war shifted not just militarily, but technologically and industrially. One captured tank, one proving ground. One group of engineers willing to look at their greatest enemy's achievement with clear eyes and ask not, how can we replicate this, but how can we defeat this? That question, answered at Kubinka, echoed through the rest of the war and into the Cold War decades that followed. If you've made it this far, you understand something that many history videos miss. Military technology is never just about the machines. It's about the culture that builds them, the industries that produce them, the doctrines that deploy them, and the leadership that learns from them. The Tiger tank was all of these things simultaneously, and the Soviet response to the Tiger, beginning with that captured machine at Kubinka, was equally comprehensive, a total war answer to a total war weapon. Subscribe to this channel if you want to understand history not as a collection of facts, but as a cascade of decisions made by people confronting impossible circumstances with incomplete information. Because that's what really happened here. That's what happens in every war that matters.